Hello, friends. Today we are going to discuss an important topic of demand analysis, namely demand forecasting. In this, we shall be focusing on two particular statistical methods, namely trend analysis and regression analysis. If you, when we go through this trend analysis and regression analysis, we will be coming to know that the methodology is the same, only the reference variables are different. To start with, let us first focus on the trend analysis, and then we shall move on to the regression analysis. In the trend analysis, when we try to see that we are only considering two variables, namely sales and time. Sales and time are the only two variables which we normally consider in trend analysis. For example, we may be given a data like years 2017, 18, 19, 20, and 21. And sales figures are only given, that is 50, 60, 65, 60, 70, and 80. This is hypothetical data relating to the sales of a particular company over the time period right from 2017 to 21. The first point of interest is to understand the long-term trend in the sales. So in simple words, in trend analysis, we are focusing on studying the relationship between two variables, namely sales and the time. So in order to understand the basically the fluctuation in sales over the time period, the first thing we do for analysis, or the first thing we do as an analyst, is to plot the line graph of taking years on the y-axis or years on the x-axis and sales on the y-axis. When we plot the graph, we get a fluctuating curve like this. So sales in the short term have been fluctuating over the time period, but in the long run, in the long term, you may be seeing that there is an increasing trend. Now, this increasing trend is approximated in the second graph by a straight line, which is observed in this particular second graph. So in trend analysis, what are we doing is we are simply estimating the equation of this particular straight line, which is known as the trend line. So in trend line, we are trying to focus on the long-term changes in the sales over the time period. So the procedure of estimating this long-term variation in the data with the help of this particular straight line itself is called as the trend line. Now, in order to estimate this equation of the trend line, if we are able to know, then and when we extend this beyond 2020, 21 to 22, 23, 24, we get what is known as the forecast of sales for the following years. Following years in the sense that is 2022, 2023, and so on. So the methodology which we follow is given in the next slide. We follow the steps like this. First is, that means we to estimate the equation of the straight line, that is the trend line. Now the general equation of the trend line is given as S is equal to A plus PT, where S is nothing but the sales, which is already given in the data, and T is nothing but time or the years, which is again already given in the data. So sales is considered as a dependent variable and time is considered as the independent variable. Now, based on the data, A and B values are to be calculated from the given data. A and B values are to be calculated from the given data. Now, in order to calculate the values of A and B, we have what we call it as two normal equations. We don't have to remember any formula for, we can say, calculating the values of A and B. What do? We try to just calculate these two particular equations, solve these two equations, and get the values of A and B. Now, what are these equations? It is nothing but summation of n times A plus B summation T. Now, this is obtained by simply remembering that put a summation symbol to this trend line, general trend line, that is summation S is equal to NA plus B summation T is known as the first equation. The second equation which is to be calculated is multiply this equation with summation T. If you just multiply it, you get it as summation S into T is equal to A summation T plus B summation T square. If we remember these two equations, half of the problem is solved. Half of the entire the job of calculating the value of A and B is entirely completed. Now I have deliberately marked the values that should be found from the given data in red color. So all red color values are obtained from the given data. So you don't have to remember anything. You just have to remember the format of the general equation of a trend line. What is S is equal to A plus BT? Put a summation symbol, so I get the first normal equation. Multiply this with summation T, you get the second normal equation. These two normal equation values are to be calculated from the table. So red color values are directly obtained from the table. For example, summation S means is nothing but the total of sales. The total of sales is given as summation S is equal to 320. So here it is 320. N is nothing but number of observations. 1, 2, 3, 4, 5. 5-year data is given. So this is 5A plus B summation T. T is nothing but taken as 1, 2, 3, 4, 5. Now, since 2017, 2018 do not have any numeric significance, they are just a reference year. In order to simplify our calculations, we consider the time as 1, 2, 3, 4, and 5. So summation T is nothing but 15. Summation T is equal to 15. So this is nothing but 320 plus 5A plus 15 times B. So one equation is over. So what are the other values to be calculated from the table? It is directly given like this, summation S into T. So I calculate S into T. S into T means sales into time. Sales into time. So when I multiply it, I get 65 into 2, 130, 60 into 3, 180. S into 2 total, I get it as 1015. So summation S into T, 1015. 1015 is obtained here. Then summation T is already here, 15, and summation T square is to be calculated. So summation T square in the sense, this one square, 2 square, 3 square, 4 square, and 5 square. Summation of T square is 55. So all the values that are required to obtain the estimated values of A and B, or to calculate the values of A and B in the trend line, are given in these normal equations. And the values that are to be calculated from these normal equations are directly obtained from this particular data. So two equations are obtained. So when I substitute these values, substitute the values in equation 1 and 2, I get two equations. 320 is equal to 5A plus 15B, and 1015 is equal to 15A into 55B. When we solve these two equations, the procedure of solving also is given here. Means I make the coefficients of A to be the same. If I want to make the coefficient of A to be the same, I have to multiply equation 1 by 3. So I get 960, 15A, and so, and then equation 2 by 1. So I get this particular answer, and I subtract the two equations. I get this value, minus 55 is equal to minus 10B, and B is equal to nothing but 55 minus 55 divided by 10. So 5.5 is the value of B. When I get the value of B, then I substitute the value of B is equal to 5.5 in equation 1. When I substitute in equation 1 like this, that is 960 is equal to 15A. 15A plus 45, 45, I get what is known as 47.5. 47.5, and therefore what I get it as the estimated trend line is 47.5 plus 5.5 T. So this is the estimated trend line, means the equation of this particular line, the equation of this line I have got, means based on the values of short-term fluctuation in sales, I have got the long-term trend variation, and this long-term trend variation is approximated by this particular equation. Now, if I want to get the forecast for the next years, if I want to get the forecast for the next, so sales forecast for the next years, I get 22, 23, 24, and 25. Next 4 years, if I want, it simply means that you are substituting T is equal to 6, T is equal to 7, T is equal to 8 and 9 respectively in the estimated trend line. Why is it? Why? How do we say? Because if you see, up to 2021 it is 5. So definitely 2022 will be 6, 23 will be 7, 24 will be 8, and 25 will be 9. So 6, 7, 8, 9 will be the later on year values for time. And those values, when I substitute those values of, let us say 6, 7, 8, 9, when I substitute 6, if I substitute, I get 80.5. If I substitute 7, I get 86. If I substitute 8, I get what is 91, 91.5, and 97 when I substitute t is equal to 9. So this is how the trend equation is used to estimate the values of sales for the coming 5 years. So the values of A and B are obtained from the given data, and from this particular given data, we are trying to forecast the value for the next 4 years, 1, 2, 3, 4. Now, this is how in trend analysis, we try to estimate the trend line as well as forecast the sales for the coming 4 years, or it can be done for coming 5 years, 6 years, and so on also. Now, when we go to the next method, that is the regression analysis, when we go to the regression analysis, the same methodology is followed. The same methodology is followed, only the reference variables are different. Now, in the last trend analysis, you might be seeing that sales was studied in relation to time. Now, here we are trying to study sales in relation to income. And years are just for reference sake, but we want to study whether there is any relationship between sales and income. And if there is sales and income relationship is there, then if a given level of income, can I forecast the sales in the future years? So here again, 17 to 21 data is given, and here the relationship to be studied is sales is nothing but a function of income. And as an analyst, the first step which I do is to plot a line graph and try to see the pattern. When I see the pattern, short term sales is fluctuating, well and good, but long term you see it's moving up. The upward tendency in the data, upward tendency in the sales as and when the income increases is approximated by a straight line in the second graph. Now this equation, or this straight line, which tries to summarize the overall tendency of increasing tendency in the data, is called as the regression line. Now we consider this as a regression line because here the variables considered are sales and income and not time. Now, when you go to the next aspect, you'll see that methodology is the same. Methodology is the same, wherein only reference variables are different. And now we have to estimate the equation of the straight line. Now it is called as a regression line because we are not considering time. And the general equation of the regression line, the general equation of the regression line, if I can just correct it, the general equation of a regression line. Yeah, regression line is given as S is equal to A plus BY. Now this has been replaced. Earlier it was T, now it is Y. Pattern of equation is same. And here again we get the values of A and B from the given data of sales and income. And A and B are to be calculated from the given data. Then the two normal equation becomes that summation S is equal to NA plus B summation Y. B summation Y. Earlier it was B summation T. Now we multiply this by y, y. So summation S into y is equal to A summation y, earlier it was t, and plus B summation y square, earlier it was t square. So here you may be seeing that only the variable is different, but the procedure is one and the same. And all the red color values are obtained from the given data. All this which is highlighted in red is directly obtained from the data. We don't have to remember anything what is to be calculated. The equation only tells you what exactly is to be calculated to obtain the values of A and B. So years are given, sales are given, income is given. So summation S is 320, number of observation N is 5, summation Y is nothing but summation of income is 200, then summation S into Y we do S into Y 50 into 20, 65 into 40, yeah, 60 into 25, 1500, summation S into Y I get, And last will say it last says that you have to calculate summation y square. So we do y square 20 square 400, 40 square 600, 25 square 625. This total we take, it is 920. Now these values are only to be substituted in the equation. Once these values are substituted in the equation, you are directly getting the equations like this. You're getting the right, substitute the values in equation 1 and 2, you get this particular type of an equation, two normal equations. Again, solving these two particular equations means multiplying equation 1 by 40. Why do I multiply 40? Because I want to make the coefficients of A and B same. If I go make the coefficients of A and B same, and we can say subtract the two equation, I can eliminate A. When I eliminate A, I am remaining with the coefficient B, and this coefficient B value is obtained as minus 650 divided by minus 1250, so it is 0.52. So I got the value of B. Once the value of B is obtained, I can substitute directly in equation 1. When I substitute it in equation 1, like 320 plus 15A is equal to 200 into 0.52. So I get the value of A. So A value and B value is obtained. We directly substitute in the equation. S is equal to A plus BY. So S is equal to 43.2 plus 0.52y. So if at all I would like, so the trend equation, the equation of this trend line is already obtained. Means what graphically we are doing is, from the given data of sales and from the given data of income, I'm estimating the equation of this particular straight line, and this is called as a regression line. The equation of this line is obtained as is 40, S is equal to 43 plus 43.2 plus 0.52y. Now, in order to get the forecast values of sales, if at all income increases in the coming years, what do I do? Sales forecast for the next 2 years, that is 2022 and 23, when income increases to 80,000 or 90,000 respectively, is obtained by substituting the values of y in the regression equation, that is S is equal to 43.2 plus 0.52y. So directly substituting, say let us say for 2022, income is given as 80. So I directly substitute to 43.2 plus 0.528, 0.52 into 80, I get the sales forecast as 84.8. Similarly, you can see that for the year 2023, when income is given as 90, if let us say income increases to 90,000 rupees, what will be the sales forecast? The sales forecast is directly obtained by substituting income is equal to 90 in the regression equation, and I get again the value of sales forecast as 90 units or 90,000 units, as the case may be. So in the two statistical methods of demand forecasting, we observe that the method is the same, but only the reference variables are different. In case of trend analysis, we considered only sales in relation to time, and the equations for deriving the values of A and B is the same. And in case of regression analysis, we considered sales in relation to income. Again, to estimate the values of A and B, the procedure is one and the same. I hope this brief introduction will help you to understand the basic purpose and the basic meaning and the crux of the regression as well as the trend analysis. Thank you very much for watching.